All right, so today we're going to talk about inscribed angles, but we've really been talking about central angles all the way up to here. I mean, I gave you a definition of inscribed angles. What's the difference between a central angle and an inscribed angle? You can actually talk. What's the definition? What's the difference? The center. And where is an inscribed angle? On the circle itself, right? So the vertex of a central angle is at the center, thus it's called a central angle. Whereas on an inscribed angle, you can see here that the vertex is right here on the circle itself. So no longer is this intercepted arc here going to be exactly the same as the angle here. So on the central angle, whatever this angle was, that was the measure of that arc, but not on an inscribed angle. So your topic, inscribed angles. And these are notes 10-4. So an inscribed angle is an angle with its vertex on the circle. Oops. That's not what I wanted to do. With two sides that are, what are these sides called? What parts of the circle?
Chords.
Chords. So with two sides that are chords.
That was for you, Miss.
Thank you so much. That looks like an A. Make that prettier. Of course. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So as we were talking about before, these are the endpoints of the inscribed angle, and that's the vertex. So that's the arc that's intercepted by that inscribed angle. The degree of the inscribed angle is equal to whoops, I can't spell today, hang on, is equal to half the measure of its intercepted arc. So let's say that the intercepted arc is x, then the angle would be 1/2 x. And the easy way to remember that is, doesn't the angle look smaller than the arc? So if you're given the arc, all you have to do is divide it by 2 to get to the angle. But if you're given the angle, how do you get to the arc? You multiply by 2. So you're either going to double your measurement or divide it by 2. And just always remember which one is smaller than the other one by visual reference. So that visually looks smaller than that one. So use that to help you out. So then we're also going to look at what happens when an inscribed angle intercepts a diameter. So as you see here, you've got from A to B to C is that inscribed angle. And BC is a chord that goes through the diameter. So there's going to be something special that happens when an inscribed angle intersects a diameter. And actually, this is the inscribed angle right here. Let's see if I can trace it. I'm going to do my best. This is the inscribed angle right here that's intercepting the diameter. So here's your diameter, because we've got this inscribed angle right here. We have this inscribed angle right here that I've drawn in, and then we have from A to C to B. So when they draw it so it looks like a triangle, you actually have 3 inscribed angles. So for right now, we're specifically talking about this one right here that I've drawn in red. So if an inscribed angle intercepts that diameter, which is this arc right here, how many degrees is this arc?
180.
180. So if this is bigger than that inscribed angle, and then the inscribed angle is half of the intercepted arc, how much do you think that angle is there? 90. Yeah. So if an inscribed angle intercepts a diameter, then it is a right angle. And the measure of angle BAC is 90 degrees. Then for overlapping arcs, if two inscribed angles intercept the same arc, so for instance, let's say that you have angle ABD. So I've highlighted that one. And then we have angle ACD. So for the red one, ABD, what's its intercepted arc? What's the arc that inscribed angle intercepts? This one right here. What's the arc? What's the endpoints of the angle? From A to D, right? And then if you look at CAD, doesn't it intercept the identical arc, AD? So here's what happens. Find a prettier color. So if two inscribed angles intercept the same arc, then the angles are congruent. So the measure of angle ABD is exactly equal to the measure of angle ACD. And so we're going to apply some of those here. So let's look at question 1. So as we look at question 1, here's your intercepted, or your inscribed angle. Here's your intercepted arc. So they've given you the arc. Which is bigger, the arc or the angle?
Arc.
The arc. So what are you going to do with 62? Divide it by 2 to get that angle. So we're going to take, for note purposes, 62 divided by 2. So what do we get? 31 degrees. Then look at angle 3. Angle 3, they want the measure of PQR. Well, again, this is a triangle, and it could be any one of the 3. Since all vertices of this triangle are on the circle, there are 3 different inscribed angles. So make sure that you figure out which one is which. So on this one, I'm going to trace from P to Q to R. So if this is my inscribed angle here, isn't PR the intercepted arc? What kind of arc is that? A semicircle, so it is. It's 180 degrees. What happens when an inscribed angle intercepts a diameter or a semicircle? Yeah, we get this right angle right here. So that means the measure of angle PQR is 90 degrees. Then look at question 4. So for question 4, they want the measure of arc BC, which is right here. Well, what is AB? Well, no, what is AB as far as chord AB? It's a diameter, right? And so you're right, the arc from A to B is a semicircle, which is how many degrees? So we know that from here to here is 180 degrees, right? And they've given us the inscribed angle right here is 47 degrees. So this is the intercepted arc AC for that angle. Yeah, is the angle smaller or bigger than the arc? Smaller. So how do we make it bigger? Divide by 2 or multiply by 2? We're going to multiply by 2 because we want to get it bigger, right? So we're going to take 47 and multiply it by 2. What does that give you? What is it? 94. So this is 94 degrees. And they want BC, so how am I going to find BC? Yeah, what's 180 minus 94? 86. So that means that this is 86 degrees. So you're going to have to use some prior knowledge in addition to your new knowledge. And then look at question 6. So question 6, they want to know what is the measure of RST. So angle RST. So angle RST goes from R to S to T. And they also want the measure of angle RUT. So we're going from R to U to T. We've got 2 inscribed angles. What is the intercepted arc for this red angle? What's the intercepted arc? Arc RT. What's the intercepted arc for this blue angle? RT. So when 2 inscribed angles intercept the same arc, what do you know about those inscribed angles? They are congruent. So I'm going to put a congruence marker here and a congruence marker there. I have been given this measure here, this measure here, and this measure here. All that's left is this unknown, which I'm going to call x. How are you going to find that?
360 minus 75.
Yeah, so we're going to take 360 and subtract from that the sum of what they have given us. So 64 plus 139 plus, I'm going to move this over a smidge, 75. So that means that x is equal to, what do we get?
82.
Let's see, 360 minus 64 plus 139. Terrific. I have my phone on. Oopsie poops. And then plus 75, right? What'd you get?
82.
82. Is that the answer to both of these, 82? If x is 82 degrees?
No.
No, because remember we're going to an inscribed angle. So is our inscribed angle smaller or bigger than that 82?
Smaller.
Smaller. So what are our angle measures?
41.
Yeah, so 41 divided by 2. So RST is 41 degrees and RUT is 41 degrees. Then the last one on this front page is going to be number 7. So for number 7, now you're getting into some expressions. So we have this inscribed angle here. It intercepts this arc. How is this related to this expression? Let's just write it out in generalities. So which one of these is bigger? Is this bigger than this?
Yeah.
Yeah, so we could take this and divide it by 2 to get that, or we could take this and multiply it by 2 to get that. Which seems like easier math?
Multiply by
Take this one and multiply it by 2. So we're going to take angle, so 2 times angle CDE. Oh, that looks like a K. Let's try that again. Angle CDE should equal the measure of arc CE. So we're going to plug and chug. So we've got 2 times 8x minus 9 equals our 158. So distribute, we get 16x minus 18 is equal to 158. What's 158 plus 18?
176.
176. And let's see if 16 divides into there evenly, which it does. So x is equal to 11. But what is the question asking us to do? So that answers the question, doesn't it?
Yeah.
What could they have asked me? They could have asked for the measure of angle CDE, but couldn't we have done that without using the expression?
Yeah.
So that's why they're not asking for that. So then this is the answer we are looking for. All right, so any questions about that? All right, so flip it to the next page.
Just the report.
What was that? Okay. All right, so let's look at number 9. So we have that triangle again in number 9, and they want to solve for x, but what they've given us is, whoops, let's see if I can get that a little bit better. They have given us this angle here in an expression. I don't know this angle, I don't know this angle, but this is a special inscribed angle. What does it intercept? What does it intercept? What's this?
180.
180 degrees. So what's this? 90 degrees. So I know immediately that this angle right there is 90 degrees. So don't I just take 90 degrees and set it equal to 13x minus 1? And they do want us to solve for x, so this should be fairly simple. We're going to add 1 to both sides. I get 91 equals 13x, and we'll see if 91 is divisible by 13, which it is. So x is equal to 7. And you could check that by plugging the 7 back in and making sure it equals 90. How is question 9 different from question 10? Yeah, you don't have this chord right here going through the center, so this chord is not a diameter. So I cannot assume that that's 180 degrees, and that definitely isn't 90, and they're telling you that it's not 90. But we do know that a triangle's angles add up to what? 180. And so this is the only angle they haven't described. They've described this angle as 114. They've described this angle as 7x plus 6. They have not given us any information on here, but we can see right here, if you look at that angle, we can see that it has that intercepted arc of 76, or what is that, 78? So if that's 78, what's this angle here? 78 divided by 2, which is 39. So I'm going to draw an arrow right here, and that becomes 39 degrees, and I got that from the arc that it intercepted. So now how do I solve for x? Now I know all 3 angles.
180 equal.
Yeah, so add all 3 of those up and set them equal to 180. So we've got 114 plus 7x plus 6 plus 39 equals 180 degrees. So add your constants together. So 114 plus 6 plus 39. So we have 7x plus 159 is equal to 180. Subtract your 159. And you get 7x is equal to 21. So what does x equal? 3. And again, you could check your answer by plugging the 3 back into the expression and adding up all 3 angles and making sure that they do add up to 180. So some prior knowledge thrown in there. So don't get snookered by some of their pictures. Then I think I'd like to do 11 while we're at it. So let's look at 11. So 11, they've given you an inscribed angle. We're solving for x. I don't know this, right? But I do know these. So I want you to get together with people that are at your normal table group. So look around, find your table group people, and I want you to discuss how you're going to set up the equation to solve for this. All right, so stop. Do you have a suggestion on how to set this up?
Hey, what the heck? We were
Well, I'm going to let you finish in just a minute. We're going to come up with the equation to solve. George? Add the arcs, the 92 and the 162, and do what with those? Okay, so what is 360 minus, I've lost my stylus, minus the 92 and the 162, it's what?
254.
No.
What?
106.
Should be 106, right? So.
Oh, yeah.
Okay, so this is 106 degrees, and we got that by adding the arcs and subtracting them from 360. So, Dustin, what are you going to do now?
I'm probably going to split 106, or put 7x minus 10 equals 106.
Are they exactly equal?
Or no, it's 2 times 7x minus 10 equals
Beautiful.
106.
So 2 times the 7x minus 10 should exactly equal the 106. So you go ahead and solve that, and I'll do it quietly up here. Oops. Oh, I added. Yeah, I needed to add. Whoops, I knew something was up. How about this? So what'd you get for x?
9.
Very good. 9 is correct. All right, then we're going to head to number 14. So as you look at number 14, they give you a lot of information in the direction, so I would actually write that on my circle. As you look at this, is TU going through the center? No, just barely not. So this is not a diameter, but this is the arc that we're looking at that's intercepted. So they give you the measure of angle STU. I'm going to write that in here. Right here, this is 5x minus 16. And then they give you the measure of SU as being 12x minus 50. We have to find the measure of angle STU. So not only do we have to find x, but then we have to go back and find the measure. So now they've given you two expressions. So we have two different ways we could set this up, an easy way and a hard way. Which one is smaller?
5x.
Yeah, so this is smaller. And then how do we make it look like that one? Multiply it by 2. So that's what I would prefer. I mean, you could take this and multiply it by 1/2 to get to that one. And actually 12 and 50 are divisible by 2, so you could do that, but I would suggest not. I would suggest that you take 2 times the 5x minus 16 and set it equal to the 12x minus 50. So then we're going to distribute, and we get 10x minus 32 is equal to 12x minus 50. Subtract the 10x. And we get a negative 32 is equal to 2x plus, how about minus? Minus 50. And then add 50. So 18 is equal to 2x. So what does x equal? 9. So this is step 1. Then step 2, we're going to take the measure of angle STU. Which is equal to 5x minus 16. And we're going to plug in what we know. So we're going to plug in the value of 9. 9 times 5 is 45, minus 16. So what is the measure of angle STU? What is it? 29 degrees. And the last one on this page that we're going to do is 16. So for 16, this time, JL is a what? A diameter. So where is the right angle? JKL, right? Isn't that the inscribed angle that's intercepting this semicircle? So our right angle is right here. So we know we have a right triangle. And so they give you the measure of JKL, and they give you the measure, which is this angle here. All right, so sorry for that interruption. So they've given you this angle here. KJL is 3x plus 2, and they've given you this angle here. KLJ is this. What do you know about the sum of these two angles? They add up to 90. So you could do this plus 90 equals 180, or you could just shorten it and say 3x plus 2 plus the 7x minus 32 is equal to 90. And then combine your like terms. So 3x and 7x is 10x. And then 2 and negative 32 is negative 30 equals 90. Add 30, what do you get? 120. Divide by 10, what do you get? 12. What are they asking for? Yeah, so that's just step 1. So step 2, the measure of KL, arc KL, has to be, has to be, so here's KL. Isn't this the angle that intercepts it? So that angle is this one here. So that's smaller than KL, right? So we're going to take 2 times this to get that KL. So the measure of arc KL is going to equal twice the measure of angle KJL. So we've got 2 times, and then we're going to use 3 times the 12 that we came up with, plus 2. So 2 times, what's 3 times 12? 36 plus 2, so 38, and what's 2 times 38? So the measure of arc KL is equal to 76 degrees. Okay, so you have a lot of problems that are like that. Then, so I've left you extra problems to do if you want to do those for more practice. So then turn to your 3rd page. Any questions on that before I flip it? Okay. So then the 3rd page is a page that says Inscribed Quadrilateral. So we've looked at an inscribed triangle. Right, the angles add up to 180 on the inside of that. We've looked at what happens when an inscribed angle intercepts a diameter or a semicircle. But in this case, we have a quadrilateral where all 4 vertices of that quadrilateral are on and touching the circle. If one of them doesn't touch the circle, this is not going to hold true. So you have to just be careful. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. What does supplementary mean? Right. So opposite angles are angles that are across from each other. So this angle here at A and this angle here at C add up to 180. This angle here at D and this angle here at B add up to 180. It doesn't matter what it looks like. It could be a square, whatever, a rectangle, whatever, and this is just an odd-shaped quadrilateral. Opposite angles are going to add up to 180 if it's in a circle. So those angles, the measure of angle A plus the measure of angle C is equal to 180. And then these angles here, the measure of angle D plus the measure of angle B is equal to 180. So we're just going to apply that here. Yes?
Is that a 3?
Oh, it's supposed to be a C. Thank you. That's supposed to be a C. I don't know. I don't even know where I got a 3 from. That's supposed to be a C. And that's an A. Are we all good? All right. So we're going to look at just a few of these. So let's look at angle 1. So angle 1, they give you some pure information. But I only know here these 2. So in order to find these are opposites, right? I don't know, you could just let it be K. So for the first one, 45 plus angle K should equal what? 180. So what's 180 minus 45? 1 what? 135. And double check your angle. Does that look like an obtuse angle right there? Whoops, I didn't hit my pointer. Does that look like an obtuse angle there?
Yeah.
Yeah, it does. And then for the second one, for angle L, its opposite angle is J. I know that because there's not a line that connects them. So we've got 92
Wait, I'm confused.
on what?
Why did you put 135 for angle J, but then you put
Oh,
angle J?
good gracious. I don't know. Why did I do
I
that?
don't know either.
Yeah.
Very
Why didn't you stop me? Let's see if I can get rid of that.
I stopped as soon as I noticed.
Oh, look at that. And that made the whole thing go away. That's all right. I'll fix it. So 45 plus angle K. Good thing y'all are paying attention to me. And so that was 135 here, right?
Yeah.
Gracias. All right. Beautiful. All right. So then what's 180 minus 92? 88. So look at your angle. Does that look like it's an acute angle? Because 88 is acute?
Yeah.
Yeah. So that should at least be true when you're doing those,
It looks just shy of a right angle.
which is hopefully what it is, right? All right, so then let's look at number 6. So number 6, a little bit more complicated. We now have an expression in here. They do want us to solve for x. Are these opposite angles?
Yeah.
And what do you know about those opposite angles? They're not congruent. They're supplementary. So we're going to take the 133 and add it to the 62 minus 5x. That is what that says, right? That's really tiny. And that should add up to 180. So then collect your like terms. So we've got 133 plus 62, which gives us what? $195 minus 5x is equal to 180. So then we are going to subtract the 195 from both sides. So we're going to get negative 5x. And 180 minus 195 is going to give us a negative. A negative what? A negative 15. And when we divide both sides by that negative 5, notice that the negatives do cancel out. And you get x is equal to what? 3. And they are only looking for x. Now, the other way that you could have done it, could you have subtracted the 133 from 180 and set it equal to this? Yeah, you can do that. That's fine. And your numbers are smaller when you do that. But I don't care. Either way, you're going to get the correct answer. All right, so then last one is number 9. So on number 9, they give you angle W. So this is angle W right here. And then they give you angle Y. And this is angle Y here. What's your equation to solve? Well, we're finding the measure of angle Y. But what's your equation to solve? What do you know about those two angles?
They're supplementary.
Right, so they add up to 180. So we're going to take the 5x, so bless you. So step 1, and again, step 1 is 5x plus 1 plus the 13x minus 37. And that should equal 180 degrees. So then add up your like terms. 5x and 13x is what?
18x.
So we get 18x. And then what's plus 1 and a minus 37?
Minus 36.
Minus 36, very good, equals 180. So then take 180 and add 36. What do you get?
216.
So 18x is equal to 216, and we'll see if 216 is divisible by 18, which it is indeed, equal to 12. But that's not what they're asking, right? As
Right.
Tristan said, they're asking for y. So then question 2, the measure of angle y is equal to 13x minus 37. I'm not done yet. Didn't ask you for that because you did it all on your calculator, didn't you? Did you write any of it out, Tristan? No.
answer?
You must write it out. I don't want to, I cannot grade what's in your calculator, right? It's not about to see who can zip through their calculator the quickest, right? So then 13 times 12 is 156 minus 37. So the measure of angle Y is what? 119. So any questions about what you guys are going to do today?